Welcome to Teja Statistics. Binomial distribution recurrence relation for the moments. Here we are learning. The PMF of the binomial distribution is given by P of x equals to NCx, P to the power of x, Q to the power of n minus x, where x can take the values from 0, 1 to n and so on n. And P is always lies between 0 to 1, Q equals to 1 minus P. The moments are given by mu r equals to expected value of x minus x bar. Here the x bar can be written as e of x also. E of x for the binomial distribution is n into p. We are substituting here. So the e of x calculation here, x minus np whole to the power of r into p of x, summation x minus np whole to the power of r. What is the p of x of the binomial distribution? Probability mass function, that is ncx, p to the power of x, q to the power of n minus x, and the x values we are taking from 0 to n. So here q is replaced by 1 minus p. In binomial distribution, p is a parameter. Now we have to differentiate with respect to p. So here is the differentiation calculation. Okay. So the derivation part is already done. So d by dp of mu r equals to 1 divided by p of 1 minus p mu r plus 1 minus nr into mu r minus 1. So here we have to derive for mu r plus 1. So that implies pq of d by dp of mu r plus nr into mu r minus 1, where q equals to 1 minus p. So this is called recurrence relation for the binomial distribution. Next, we are going to learn about the Poisson distribution. So let x be a discrete random variable is said to have a Poisson distribution, then its PMF is given by P of x is equals to e to the power of minus lambda, lambda to the power of x divided by x factorial, where x can take the values from 0 to infinity and lambda is greater than 0. Mathematically we can denote x follows Poisson of lambda. So the movements of Poisson distribution we have to learn. So what is the movements? The mean and variance. To derive that one, the PMF of the Poisson distribution is e to the power of minus lambda, lambda to the power of x divided by x factorial. So mean is equals to e of x, that is summation x into p of x, x into e to the power of minus lambda, lambda to the power of x divided by x factorial. So if you simplify that one, x e power minus lambda, so this can be written as x into e to the power of minus lambda, lambda to the power of x divided by x, x minus 1 factorial. So x gets cancelled and e to the power of minus lambda is a constant putting outside. So we are just expanding this one, as you can see. So e to the power of, if you common the lambda value, this will be the formula of e to the power of x, that is e to the power of lambda. So e to the power of minus lambda, e to the power of lambda will get cancelled, and the mean of the Poisson distribution we got lambda. For easy and simple calculations for e of x square, that is mu 2 dash x square, can be written as e of x minus 1 plus e of x. We are trying to find out the e of x minus 1. So summation x of x minus 1 and p of x e to the power of minus lambda, lambda to the power of x divided by x factorial. So if you 2 times taken that value, okay, of the factorial, then you will get like this: x of x minus 1 e to the power of minus lambda, lambda to the power of x divided by x of x minus 1, and factorial will continue from x minus 2. Both will get cancelled, and this is the final value e to the power of minus lambda. The summation is starting from 2 onwards. Okay. Next, e to the power of minus lambda is common. So, if you substitute the values of 2, lambda square divided by 0 factorial, lambda cube divided by 1 factorial, and so on, you are getting. So, this is the value of e of x square. So, e to the power of minus lambda is putting outside, and taking the common value as lambda square. This will be the form of the e to the power of lambda. So here you can write the e of x minus 1 value as lambda square, and if you wrote the value of e of x square is equals to lambda square plus lambda. The variance for this Poisson distribution is e of x square minus e of x whole square, or else we can write mu 2 dash minus mu 1 dash whole square. So this is the value of mu 2 dash. Okay, so you just substitute the value for the variance, lambda square plus lambda minus lambda square. Both will get cancelled, and the variance value of the Poisson distribution is lambda. Okay, so here both the mean and variance are equal for the Poisson distribution. Next, look at the value of the MGF of the Poisson distribution. The PMF of the Poisson distribution is given by P of x equals to e to the power of minus lambda, lambda to the power of x divided by x factorial. The mx of t value, e of e power tx, summation e power tx and p of x value. Okay, e power tx and e to the power of minus lambda, and lambda to the power of x divided by x factorial is the p of x value. So if you put e to the power of minus lambda putting outside, the summation will come for this only: lambda into e to the power of t whole to the power of x divided by x factorial. So if you expand this one, this is in the form of the e to the power of x, then so in place of x you have lambda into e to the power of t. So e power minus lambda and e power lambda into e power t. So this is if you common the lambda value, then e to the power of t minus 1 is the mx of t for Poisson distribution. From that we have to derive the mean value, or else we can say that mu 1 dash. So d by dt of mx of t at t equals to 0. D by dt of mx of t, what we got, e to the power of lambda, e to the power of t minus 1, and at t equals to 0 you have to differentiate with respect to the value of t, and putting the value as t equals to 0. So uh, if you apply the formula over here, then you will get the value as lambda. Okay, the mean of the Poisson distribution is lambda. Next, mu 2 dash d square by dt square of mx of t at t equals to 0. So here we have to use d by dt of the above value before substituting t value as 0. So e to the power of lambda of e to the power of t minus 1, lambda into e to the power of t. So putting lambda as a constant, and if you apply the UV formula over here, then you will get mu 2 dash as lambda square plus lambda. Okay, by substituting t equals to 0. The variance, as you all know, e of x square minus e of x whole square. So lambda square plus lambda minus lambda square. So both will get cancelled. Again the variance you got from the uh, MGF for the Poisson distribution is lambda. Okay, So this is how you have to derive for the Poisson distribution, MGF, and mean and variance. Similarly, you can able to solve the CGF of the Poisson distribution also. Okay, this is we are going to discuss in the next session. Thank you.